So vector space. To say vector space, you need first there is some field. Let us write k plus, but I specify this k. It is plus on k and multiplication on k. So I first assume this, and there is some field, and you have another set V. And when you say vector space, you focus on below three things. I'll say V plus heart. So plus and heart is plus is a binary map, V times V to V, and heart is some combination of field times V to V. So these two operations are well defined, and V is just set. On a field, if you have these three things satisfying some axiom, I write follow in below, it is called vector space. So what is vector space? This should satisfy some axioms. So plus is simple. When you see plus, it is just abelian group usually. So plus V plus is abelian group. I'll not say much, but maybe I do better write. So it should be commutative, associative, and there should be neutral element. There should be also inverse. Maybe let us write. Commutative means for or V1, V2. Let me always V1, V2 in V. You can choose and some A, B in K. Commutative means V1 plus V2 equals V2 plus V1. Associative means V1 plus, let me say V3 also. V2 plus V3. If you have this order, it is same with V1 plus V2 plus V3. This is associative. Neutral element, there is some zero element in V, such that for all V, I thought I not write, but I'm writing. For all V, 0 plus V is V plus 0 is V. And inverse means that there is, for all V in V, there is a minus V in V. So there is always something in V which satisfy V plus minus V, or minus V plus V is 0. This 0 is, of course, this identity element 0. Oh, I didn't write. This should be V. And we usually, instead of writing this, we usually write this as V minus V. So this is what you know about plus. And because this heart is not V times V to V, it is randomly mixing, so there is some heart should have some property. So heart is associative also. But with K. It means that if you have A, B, V, you can have, of course, you can multiply A, B, V, and this and this. Then let us see. A and B times V is heart, so B times V is heart. A times B times V is vector, so A heart, B heart, V. Similar, A, B heart, V, but in here you have multiplication of numbers. So it is associative but a little bit different from the vector case because it is just changing the parenthesis, right? And I don't know, you change this parenthesis, you can change, you can point out my pronunciation. Yeah, associative but different manner from others we run before because that is different. And also, and heart is also distributive. Oh, there's two, say, on this one, the other is this one. So maybe I can write separately distributive between heart plus, this case is something like A heart V1 plus V2 is A heart V1 plus A heart V2, but also it is distributive on this one. Then A number plus B is times V equals A heart V plus B heart V. So in this case, you can see that plus of number is not only distributive, but it changes to just plus of vectors. So it is a little bit different from the above case. In above case, vector plus becomes vector plus, but in the below, you also change number plus to the vector plus. And finally, you have some unity of axiom. It is just for the multiplication identity, 1 times 1 heart V equals just V. So it says that it gives some standard to say what is multiplication behave. 1 is doing nothing, and then what you can define others according to this. So if you have these two operations satisfying the following multiplication, some following operation rule, and with this set, you say V plus heart is a vector space, and then this heart is called scalar multiplication or simply S multiplication, and this plus is called just vector addition. So vector space nothing but just the set whose addition and S multiplication is well defined. It is what we call vector space, and because it is this S multiplication is defined with another field K, we say on K. But it is too long to write, so some people just write V is a vector field on K. It is also too long. Some people say just V is K vector field. Also, it is too long. Someone say just V is vector field. Recall that K is just number. So there are two vector fields, R vector field. You will meet C vector field. This is what you will meet most case. This is called real vector space. This is just a complex vector space. Let me write just CPX, complex vector space. So now you know what is vector space. In fact, what basic thingy? you run when you run physics at first course. I think you run vector. You meet vector in your first time in your life in a science or physics class. So using arrow, so you say some arrow is vector, and you don't just do this. You have some S multiplication and addition. For example, if you have V and W, how you can add them? You can just you copy and paste. Oh, you move here maybe, or you draw a line joining tail and head of this. This is V plus W. And this is how you define addition. And what is multiplication? If you have some vector V, for example, if k is 2, 2V is this one. 2, maybe because I want to keep this notation, heart V. So you define as multiplication by changing the length. This length becomes 2V if this length is V. So changing length is multiplication, and addition is defined like above triangular formula. And you know, you already learned that some people prefer to use some parallelogram. Parallelogram means that when you add them, you just draw another I don't know how to paste, just I do it. Okay, you draw another parallel line W and then parallel line V. Then you can get same arrow. It is also U, V plus U, W. It is just directly showing what is it is commutative. So V plus W is W plus V. And you can easily check these axioms. Associative, neutral element is just zero vector, inverse is minus. So in this case, everything you have this one, you have some vector with the opposite direction. This is V, this is minus V. So there is a minus inverse of addition. And you know, or you already learned how it is associative and distributive, and also 1 times V is does not change the length of the arrow, so it does not change anything. So what you run vector was the element of vector space where the set V is some just we can define such that set of all arrow. Maybe in the note, in the plane, for example, and plus is triangle addition, and scalar multiplication, S multiplication is just length multiplication, length change, maybe TH. So this is the vector. So now you can see that I tell vector space, and when I tell vector space, the important thing is you need set, not only set, you need also addition and scalar multiplication. It becomes different in each case, so you need always check it if it is S multiplication or not, it is addition or not, by checking the axioms satisfied or not. If you check every addition and multiplication, and of course they should be closed because in the definition they are closed. So if you can check everything is closed and satisfying the axioms, you can say this is vector space. One of the, I think others are very trivial. One of the non-trivial example is just numbers. You might think this is, we already know this is field, real number field. One thing I want to show today is that this is a real number field, so addition is abelian group, and this product, let us say product in real number, you know how to multiply real numbers. 3 times 4 is 12, something like that. And this number product, it is also unitary division ring, or just this is field, so that is what you call field. But because plus is also abelian group, and this scalar multiplication satisfies all the axioms above. So this you choose this as same thing as some vector and some operation. Let's say you choose set an operation, then R plus is also addition is still abelian group because it was already abelian group. And interestingly, so this number multiplication is of course maybe to make a difference. Let me write just red. It is just same, but I write red. So you can say have plus, red plus is something like that, number a plus b, and this scalar multiplication is red number to red 2, black thing to this. Why I write this way? Because I want to say one is field, the other is vector. Vector space element. If you choose same real number, because R plus is abelian group, what you want to check is this is associative, distributive to distributive, and 1 times some number is 1. So this is true, and associative is true because it is field, and distributive is also true because it is also field. So you can say, interestingly, if you don't believe, you can check. This one is also a vector field on R. But this is just real number. Why you make some different color? So can I change? No. Okay. So what I show is I use color, but it is just real number, so you don't need to distinguish. So what I show is just R is a vector field on R, or R is just a real vector field. Sorry, I should not use field. Real vector space, it is my mistake. Vector field you will learn very later, not now. Space, space, space. So numbers are also a vector space. So yeah. Do I write wrong? Write wrong. Sorry, this is our vector space. I don't know why I have too much obsessed with vector field, but it is our it should be our vector space. I'm sorry for make confusion. Yeah. Okay. Anyway, so today I show what is vector space. what you should concentrate is, I want to emphasize the operation, not only set. Vector space is a set with operations, and operations are very important. And also, I don't say vector much, I say only vector space. In fact, what I want to say, another thing is that vector is nothing but element of vector space. Okay, maybe I can give you some simple example. Similarly, you can define complex number, and complex number can, with the same, you can do the same thing. So complex number is a complex vector field. Then what happens? And also, complex vector is a real vector field. So you can define also complex number on a field real number. How about if you choose R on a with a complex number? Unfortunately, if you multiply real number to the complex number, in here, what you want is that if you multiply field to the vector, you want vector. So it means if you choose C, complex number times real number to be a real number, but you already know complex number times real number is in general not a real number, so it's not a vector field. If someone asks number 3, is number 3 vector? You might say yes, you might say no. It depends on what is vector space. So you need set, operation. Not only this, you need also field. So if you check everything, you can say it is vector or not. So if asking something is vector is usually this question, you should always ask what is the vector space. Of course, in physics you meet always what is vector or not. I'll answer very later what is the implicit assumption behind the question what is vector, because it is one of the things appears a lot in physics literature. So I'll write it later, but at this level of just you first learn just vector space without anything, any assumption on topology, without any assumption on vector, metric, anything. What is vector? You don't know. Just you need to tell us that what is vector space.